All right, in this video, I want to talk about what happens when you multiply a function by a number. And we're going to start off by multiplying by a -1. All right, and again, we're going to have an inside transformation and an outside transformation. So let's start on the outside of this function. Let's turn on our second graph using square root of x for this one. And I'm just going to multiply by -1. So I'm just putting a negative sign in the front. All right, and what this has done is it's taken all the y coordinates and multiplied them by -1. Okay, so it just kind of flipped them down to negative y coordinates. So this causes a flip or a reflection over the x-axis. So you can either describe this as a reflection over the x-axis or as a vertical reflection. Whichever one reminds you of the right thing, use that phraseology. All right, so let's see what happens when we put the negative on the inside of the square root. All right, so I'm going to hide this one while I type this in. All right, so I'm going to put a negative on the inside. And that should look a little weird to you. I've spent a lot of time harping on the fact that we don't take the square root of a negative number. Okay, but watch what happens where this graph is. When I turn it on, okay, you actually get this graph to exist over the negative x-axis. So think about that. If you plug in -1 for x, the function has a negative, and then the number has a negative, and they cancel each other out. So this function exists. It really likes those negative numbers over there on the left-hand side of the x-axis, because the negatives cancel out and you actually get y coordinates. But physically what's happened to this graph, it's another flip. This time it's a horizontal flip over the y-axis. Okay, so I like describing these flips as being either vertical or horizontal because the vertical flip happened when we put the negative on the outside, just like vertical shifts happened when we added or subtracted outside the function. When you move inside, that's when you got those horizontal shifts left and right, and that's when you get the horizontal flip. All right, so let's go write these down. So we got two new rules, one for multiplying f of x on the outside by a -1, and one for multiplying by -1 on the inside for the x's. All right, so when we did it on the outside, remember doing things to the outside affects a vertical change. So this is the graph of f of x reflected vertically. And if you like to say that's over the x-axis, that's easier for you to remember, then you can say it that way. All right, and you can also say flipped. Reflected is more of a mathy word, but either one is fine. And then the graph of f of -x, so we've moved that negative multiplication to the inside, so it affects a horizontal change. Okay, so this is going to be reflected or flipped horizontally, i.e. over the y-axis. All right, we've got one more rule to look at, and we'll do that with the cube root of x graph. All right, here we've got our cube root of x graph. We're sticking with the process of multiplying by a number. Okay, so I'm going to multiply on the outside. And let's give this a number like 3 and see what that does to the graph. What in the world is going on here? All right, so remember that we have to describe this as something vertical because we've multiplied on the outside by something. Okay, so what's happened is if you imagine grabbing the tail ends of the red graph, the red dotted graph, okay, what has happened is we've multiplied those y coordinates by 3. We've tripled them in height. Okay, so everything positive got more positive, everything that was negative got more negative. Right, so we have vertically stretched this graph. Okay, sometimes a vertical stretch looks like it's made things kind of squished this way. Okay, but if you're multiplying on the outside, we always want to describe that as a vertical thing. We're going to describe this as a vertical stretch. And it got stretched because the number 3 is bigger than 1, right? We're making it even bigger. Okay, so it actually depends on what size of number you multiply by. All right, so I'm going to go over here. I'm going to get rid of the 3. And now let's multiply by something smaller than 1. So let's take 0.5. All right, so this one, again, describing it vertically, we've taken those y coordinates and we've chopped them in half by multiplying by 0.5. So everything has gotten shorter. So this is going to be a vertical shrink. Okay, so vertical stretches and shrinks happen when you multiply by a number. If the number is bigger than 1, then it's going to stretch. If it's smaller than 1, it's going to shrink. And a good way to remember the difference between stretches and shrinks is to think about multiplying your paycheck by a number. If I multiply your paycheck by 3, I'm stretching it. If I multiply your paycheck by 1/2, I'm shrinking it. Let's go write this rule down. All right, our last rule is about multiplying on the outside of a function. So we're going to say a times f of x. All right. So again, we're going to describe this as a vertical transformation. This is the graph of f of x vertically stretched. Okay, that happened when a was a big number, something bigger than 1, or vertically shrunk. Okay, and that's going to be if a is a small number between 0 and 1. Okay. If a happens to be a negative number, we're going to think about that as two separate transformations, the negative being the flip and then the number being the stretch or the shrink. All right, let's go see what happens to some other graphs whenever we stretch them or shrink them. All right, so here we have our regular old x squared parabola, and I'm going to multiply by a number. Let's start off with a vertical shrink. I'm going to multiply by something smaller than 1. How about a third? And let's see what happened here. All right, so we know we have to describe this as a vertical transformation. This is a vertical shrink. It has the visual effect of making this look like it got fatter. It's like when you see a TV where the aspect ratio is set incorrectly, where it doesn't give enough room in the vertical direction, and it makes everybody on screen look like they got wider, but really they've just been kind of compressed vertically, okay? And then the same sort of thing happens if I make this a big number. So if I multiply by, let's say 2, okay. Again, it has the visual effect of looking like it got skinnier, but really what's happened, we've doubled all the y coordinates. So we've kind of taken the ends of those red dotted graphs and we've stretched them up by a factor of 2. So visually it looks like they got skinnier, but really they got vertically stretched. All right, so when we meet together in class again, we're going to take that handout with all the rules and get used to all these transformation rules.